So in this series of lectures, I'm going to show you how to calculate the two different chi-square tests. The chi-square goodness of fit test, which has two options, either when the expected frequencies are known and when the expected frequencies are not known. And then also the chi-square test of independence. The formula is the same for all of them, which is chi-square obtained is going to be equal to the sum of, and then this entire formula here, right? Sorry. Oops, this is not what I wanted to do. Okay, the sum of this entire formula here, okay, and that is the observed frequency minus the expected frequency squared, and then you divide that difference squared by the expected frequency. All right, so basically the first thing that we need to do is we're going to need to specify our hypothesis. And in this case, the hypotheses tend to be written out in sentences. So what I am going to do is I'll type them up here. Okay, so our null, sorry, first, our null hypothesis, actually, I'll just do that. So our null hypothesis, H, oops, that's not what we want to do. Sorry. Here, we'll do it down here. We'll do it here. So H sub 0 is going to be the proportion of different types, sorry, of pets. Oh my goodness, we'll get there yet. Pets owned by TU students will match the, well, not March, will match the proportion of different pets owned by people in the U.S. population. So in other words, we're basically just saying that here that there's going to be no difference, right, in the proportions of different types of pets owned by TU students and the proportion of different types of pets owned by non-TU students. So we're going to we'll select, let's see if I can do that. Okay, hold on. Okay, we're going to copy that. Oops. Oh my goodness. Okay. Control C. I'm going to copy that, and then we're going to change that to our alternative hypothesis. And in this case, we're just going to add in the word not, match the proportion of different pets owned. Should put the word pets in here and here. Okay, so that is our null and our alternative hypothesis. And then we're going to calculate our degrees of freedom. And what we can see here is that our degrees of freedom is going to be equal to k minus 1, where k is the number of groups. Oops, oh, for goodness sakes, I'll get used to this yet. K is the number of groups. So we have 1, 2, 3, 4, and 5 different types of groups. So that's going to be equal to 5 minus 1, which is going to give us degrees of freedom of 4. So in order for us then to find our critical value against which we will evaluate our obtained chi-square, we need to go into the table in our textbook. We will use, as usual, alpha equals 0.05. So go to the column that says 0.05 level, scroll down to the degrees of freedom, which is 4, and that's going to give us a chi-square critical value of 9.488. Okay, so the next step then is to actually determine the, the next step is now to determine the observed, the expected values, okay, and we do that by basically multiplying the proportion. So expected frequency is equal to the proportion of the target population characteristic. So we're talking about a specific characteristic times n. Okay, so since our target population is the United States, right, we want to be comparing this sample of 100, so I have a sample of a made-up sample of 171 TU students, ask them what types of pets they owned, and so what we have here is made-up data about the types of pets owned by people in the U.S. in 2018. So none of them, 10.25% had no pets, 46.34% had dogs only, 18.7% had cats only, 19.28% had dogs and cats, and then 5.43% had other. And then if we look at the frequency, what we call the observed frequency of pet ownership among TU students that were sampled, 30 had no pets, 65 had dogs only, 40 had cats only, 26 had dogs and cats, and 10 had other types of pets. And if you were just to eyeball it, it would look like, okay, so that sort of mirrors these frequencies, but we really need to be able to compare these observed frequencies to the expected frequencies. So what we're going to do is we're going to convert these percentages here into proportions, and we're going to multiply them by n, which is the sample size of TU students, and that will then give us the expected frequency for each of the categories. So we're going to say, okay, so we want to know what is the expected frequency if TU students did in fact match the same proportion of pets as the US population, then what proportion of pets students would we expect to have no pets? So we're going to basically take that that percentage, we're going to convert it to a proportion. So 1.1025, and we're going to multiply it by 171, which is the n. And we are going to then fill that value into our table. And that value is going to be 17.53. And so just for this first one, we can see that if the expected frequency should be 17.53, that more TU students than the US population have no pets. Okay, and then if we want to do the next one, we're going to take 0.4634, and we're going to multiply that by 171, and that's going to give us a value of 79.24, and it seems that TU students are less likely to have only dogs. And then we're going to have, for the cats only, 0.1870, multiply that by 171, and that's going to give us a value of 31.98. And then 0.1928 times 171, and that's going to give us a value of 32.97. And then we're going to take 0.0543, and we're going to multiply that by 171. And that's going to give us a value of 9.29. Now, to be sure that we did this correctly, that our math is not wrong, what we're going to want to do is add these values up, because they should also equal 171. And essentially what these values represent is if the proportion of different types of pets among TU students match that of the US population, then this is the number of students who should have none, this is the number of students who should have dogs only, this is the number of students who should have cats only, so on and so forth. And so we're going to eventually calculate the difference between the expected frequency based on these proportions and the observed frequency based on the data we've actually obtained. So we're going to add this up. So we've got 3 and 4 is 7, and 8 is 15, and 7 is 22, and that's going to give us 31. We're going to carry the 3, and 5 is 8, 10, 19, 28. Wait a second. 3 and 5 is 8, 10, 19, 28. Right, that's 30. My apologies. And then we're going to carry that 3, and 7 is 10, 19, 20, 22, 31. And then we have 3, and 1 is 4, 11, 14, 17. So the fact that we get 171.01 as the sum of our expected frequency is close enough to 171 to suggest that our math was correct. All right, so the next step then is to calculate the difference between the expected frequency and the observed frequency, right? So the expected frequency is frequency based on US population proportions, and the observed frequency is the actual number of pets that students have. So we're going to do 30 minus 17.53, and that's going to give us a difference of 12.47. And then we're going to subtract 79.24 from 65, and that's going to give us a difference of negative 14.24. Sorry, decimal point there. And then we're going to do 40 minus 31.98, and that's going to give us a difference of 8.02. And then we're going to do 26 minus 32.97, and that's going to give us a difference of negative 6.97. And then finally, we're going to subtract 9.29 from 10, and that's going to give us a difference of 0.71. Okay, so as with in any case, we're not going to want to add up our positive and negative values because it's not going to give us an accurate representation of the true difference, so we're going to square those values. Okay, and so as I will sort of remind you about the formula for the chi-square test, we need the observed minus the expected frequency squared. So we're going to get the top half of that part of the equation. All right, so 12.47 squared is 155.5. 14.24 squared is 202.78. 8.02 squared is 64.32. And then 6.97 squared is 48.58. And then 0.71 squared is going to be 0.50. And then the last thing we need to do is then divide in order to fulfill our equation. We need to divide these values by the expected frequency, which is this. So we're going to basically divide 155.5 by 17.53, right? So 155.5 divided by 17.53, right? And then we're going to also do 202.78 divided by 79.24. And so we're going to get 8.87, 2.56, 2.01, 1.47, and 0.05. And I will continue this on the next video.